As the demand for renewable energy sources continue to grow, the need for efficient and reliable energy storage systems become increasingly vital. Energy storage technologies play a crucial role in managing the intermittent nature of renewable energy generation and ensuring a stable and consistent power supply. One promising avenue in the field of energy storage is the use of chemical compounds. Next, I will talk about the laws of thermodynamics. The laws of thermodynamics play a crucial role in understanding the storage of solar energy using organic compounds. The first and second laws are relevant in this context. The first law of thermodynamics states that energy cannot be created or destroyed. It can only be converted from one form to another. When it comes to storing solar energy in organic compounds, this law emphasizes the need to conserve energy throughout the process. It implies that the energy obtained from the sun must be efficiently captured and converted into chemical potential energy within the organic compounds. The second law of thermodynamics relates to the concept of entropy, which measures the degree of disorder or randomness in a system. In the context of organic compounds storing solar energy, the second law highlights the importance of minimizing energy losses and maximizing energy conversion efficiency. This law indicates that some energy will inevitably be lost as heat during conversion and storage processes. Hence, it is crucial to design systems and processes that minimize such losses and maximize the usable energy stored within the organic compound. Overall, the laws of thermodynamics underscore the importance of energy capture, conversion, and storage when utilizing organic compounds to store solar energy, emphasizing the need for optimized systems to make the process more sustainable and effective.
For problem statement, in this case study, we are researching for 4 compounds, which is propane, octane, methane, and also ethanol, to see which of among them are best to store energy and also at the same time sustainable, affordable, and efficient. To achieve our objectives, we design a research work and provide experimental data with calculation to get delta H combustion for each organic compounds. This is because the most suitable compound to be used must be sustainable for our planet, and their delta H combustion must be high at the same time.
Aside from octane, our team is proposing the use of methane as an organic compound to be used as energy storage. In terms of sustainability, even though methane is a potent greenhouse gas and contributes a lot to climate change, a relative sustainable means of production can be carried out like anaerobic digestion of organic waste by microorganisms. Methane also releases a relatively large amount of heat as it combusts, making it really efficient in storing energy. Lastly, it exists in abundance worldwide, making it highly accessible. Farm owners and even local residents can utilize the sources they have at hand to generate income and also at the same time growing the local economy.
The second compound we would like to propose is ethanol, which is also known as C2H5OH. We choose this compound based on 3 criteria: sustainability, efficiency, cost, and accessibility. The first criteria, sustainability. This compound is said to be very sustainable because of how it is produced. It is produced from renewable resources such as sugarcane, corn, and cellulosic feedstock, which means the source of this compound is not limited. Second, every time this compound is produced, it has a very low carbon emission, which means it will not have a toll on our nature and it will not harm our nature. The second criteria, efficiency. This compound is very efficient because it is used in many industries. One of its purposes is to act as a fuel in a combustion engines and act as a fuel cells. The third criteria, cost and accessibility. As I said earlier, the source of this compound is not limited, which means this compound is readily available around the world, especially in regions with a developed biofuel industry.
Another organic compound to be proposed is propane. Propane is a hydrocarbon compound which is versatile and sustainable energy source. We choose propane because it is readily available from the byproduct of the natural gas processing and petroleum refining. Besides, it is a non-toxic substance and not harmful to the ozone layer. We can use propane for the water heating, cooking, or act as an alternative fuel for vehicles. To calculate the heat of combustion of propane, first we have to write out the chemical equation of the combustion of propane. 1 mole of propane reacts with 5 moles of oxygen will produce 3 moles of carbon dioxide and 4 moles of water. The heat of combustion is equals to the summation of heat of the product minus the summation of the heat of the reactants, and the answer we get is negative 2219. That we use the answer divided by the mass of 1 mole of propane, and we get the energy released by the combustion of propane is negative 50.432 kilojoule per gram, and this is the energy content of the propane.
So we have gone through 3 different types of compounds, which are methane, propane, and ethanol. But what's the most optimal option? Well, based on our research, we have concluded that methane is the most optimal solution if produced through sustainable methods that are environmentally friendly. Now, why do we choose methane? Because it's relatively plentiful and low cost, which means it doesn't cost a lot to store it as an energy form. Furthermore, it's also produced through environmentally friendly methods to make it very sustainable, such as biogas production and carbon capture for utilization. Furthermore, we have also concluded that methane produces the highest energy per unit mass, which is 56 kilojoules per gram. Now, I don't know about you, but I love me some high energy. So, this is Group 10, signing off. Thank you.